Welcome, and now we're going to look at multiplying algebraic expressions. To find the product of polynomials or other algebraic expressions, we need to use the distributive property repeatedly. Right? So here, if I want to multiply a plus b times c plus d, I need to distribute the a, the first term, to the second binomial, the second expression, and the second term to the second binomial. Now you could also think of this as FOIL, right? The first two terms, the outer, the inner, and the last two terms. But FOIL only works if we're multiplying a binomial by a binomial. It doesn't work if we have three terms. So that's why thinking of it as distribution is a lot more useful, because we can use distribution, multiplication by distribution, for any number of terms. So now let's look at 2x plus 3 times x squared minus 5x plus 4. If we want to multiply those two expressions together, we need to distribute the first term in the first expression to all the terms in the second expression. So we have 2x times x squared minus 5x plus 4. And then we need to distribute the 3 to all the terms in the second expression, x squared minus 5x plus 4. All right, so when we're multiplying polynomials, we want to make sure we multiply every term by every other term, right, in the other expression. So that's why FOIL works, right? Because first we multiply the a times the d, and the a times the c, and then for the last we multiply the a times the d. So we've made sure that we've distributed the a to both the c and the d. For the outer and inner, we multiply the b times the c and the b times the d. We make sure that we distribute that b expression to both the c and the d. So notice that every term in the first expression has been multiplied by every term in the second expression. Right? This is an easier way to write it when we have more than just two binomials, because we have to make sure we multiply every term in the first polynomial by every term in the second polynomial. All right, so let's do the multiplication now. All right, so we have 2x times x squared. That would be 2x cubed. Right? We add exponents when we multiply, like bases raised to a power. 2x times negative 5x would be a negative 10x squared. And 2x times 4 would be 8x. Now let's do the same thing with the 3. 3 times x squared is 3x squared. 3 times negative 5x is negative 15x. And 3 times 4 is 12. Let's combine the like terms. So there's only one cubic term. So 2x cubed. We have two squared terms. We have negative 10x squared and a 3x squared. So negative 10x plus 3x would be negative 7x squared. And we have 8x and negative 15x are like terms. So 8x plus negative 15x would be a negative 7x. And then we have one constant term, plus 12. And there we go. That's all there is to multiplication. Just make sure you've multiplied the second polynomial by every term in the first polynomial. I'm going to pause and let you do a couple practice problems, and then we're going to look at special product formulas. Now for these problems, you can certainly use multiplication by distribution, just what we've done here for multiplying these two polynomials. But there are some times when you can use a shortcut, and I want to share those shortcuts with you so you can use them as well. So I'm going to pause for now so you can do a couple practice problems, and then we're going to look at special product formulas. Thanks for watching. Bye for now.